Today we're going to be running an Ancova. We are looking at a person's happiness levels on a scale of 0 to 10 after they completed therapy with a puppy. We have 3 different dosage groups. Our first group is our control group, and they played with a stuffed animal for 15 minutes. Our next group is our low dosage group. They played with a real puppy for 15 minutes. And our high dosage group is a group that played with a real puppy for 30 minutes. After playing with the puppy, whether real or a stuffed animal is in the control group, they gave their happiness rating. The researcher also knows that someone's general love of puppies might affect their ratings after playing with a puppy. So she queried their love of puppies on a scale of 0 to 7, with 7 being super ecstatic about dogs and puppies, and 0 being that they hate dogs and puppies. So now we're going to run our Ancova. We will first check our assumptions. The first one we're going to do is linearity, so we'll go to Graphs, Legacy Dialogues, Scatter Dot, and select the simple scatter. Select Define. We will move our dependent variable onto our x-axis and our covariate onto our y-axis. We want to ensure that there is a linear relationship between our covariate and our dependent variable. We'll then select OK and examine our output. So for the most part, we can see there is a linear relationship. There's a couple down here that we would consider outliers, but for the most part, we will consider this to be a linear relationship. We will want to check and see that our covariate love of puppies does not differ across the 3 dosage groups for our independent variable. To do this, we'll go to Analyze, Compare Means, and run a simple one-way ANOVA. We will put our love of puppies as our dependent variable and our dosage as our independent variable. Select OK and examine our output. We can see that there is not a significant difference in love of puppies in general across the 3 dosage groups, indicating that this is a good covariate to use in our analysis. So now we're going to run our main analysis, which is an Ancova. So we will go to Analyze, General Linear Model, Univariate. We're going to put our dependent variable in the dependent variables box. Our love of puppies will go in the covariates box, and our dosage will go in the fixed factors box. The first thing we're going to do is we're going to select options, and we want our homogeneity test, descriptive statistics, and estimates of effect size. Click Continue. And we're also going to go ahead and ask for estimated marginal means. This is going to conduct our post hoc tests if needed. So we'll select EM. We want it for our independent variable, display means for. Then we're going to compare the means, and we're going to do a Bonferroni adjustment. Click Continue, and then click OK. Very similar to our two-way ANOVA, we have our descriptive statistics and between subjects factors at the top, so we can see that we have 9 people in the control group, 8 in the 15-minute group, and 13 in the 30-minute group. So this is an unbalanced design with 30 participants total. Next, we see our Levene's test. We do not meet the assumption of homogeneity of variance because our p-value is less than 0.05. It's 0.019. However, we're going to continue the analysis for this example. Down here, we see our between subjects effects table. Again, we're going to ignore the first 2 lines, corrected model and intercept, as well as the total. We first want to look at our covariate, puppy love, and ensure that it has a statistically significant relationship with our dependent variable. If it does not have a significant relationship with the dependent variable, it is not explaining a significant portion of the variance in the dependent variable or happiness levels, so we would want to remove it from our analysis. So we'll look at the puppy love line. We can see that it has a sum of squares of 15.076, an F statistic of 4.959 with a significance value of 0.035, indicating that it does have a significant impact on happiness levels, so we will want to keep it in our analysis. Next, we're going to look at the dosage or our independent variable and see if it has a significant main effect on happiness ratings. We can see that it has an F value of 4.142 with a P value of 0.027, which is lower than our alpha of 0.05, indicating that there is a significant effect of dosage on a person's happiness levels. We can also see that it has a partial eta squared of 0.242, indicating that 24.2% of the variance in happiness levels is a result of the dosage that they received of puppy therapy. Next, we'll go down here since we did have a significant relationship and our dosage does have more than 2 levels, we will need to look at our post hoc tests. The estimated marginal means does something specifically for an Ancova that a post hoc test in general would not do if you were to run it in, say, a two-way ANOVA. In the estimated marginal means section, what it does is it removes the variance first of our covariate. So it adjusts for the covariate before conducting the post hoc tests. So our univariate test here at the bottom shows the exact same thing that our between subjects effects did above. We have a significance value of 0.027, and again, 24.2% of the variance is explained by the dosage levels. So now we need to look at our pairwise comparison table to see where those differences lie. We can see on our first line that the control versus the 15-minute group did not have a significant difference. However, the control versus the 30-minute group did show a significant difference in their happiness ratings with a p-value of 0.031. Our 15 compared to our 30-minute group also did not have a significant effect with a p-value of 1. So this means that of the 3 groups or the 3 pairs, only the control versus the 30-minute group showed a statistically significant difference in happiness levels after spending time in puppy therapy.